Okay, this is lesson 3-8. It's the last lesson of this chapter. It's called Analyzing and Sketching Graphs. 3-8, Analyzing and Sketching Graphs. Okay, so the first thing we're going to look at is this picture right here. If you want to draw this picture, you can. With this stuff, don't worry about these definitions, but you can draw this, okay? So we're looking at analyzing types of graphs and then sketching them. So graphs show the relationship between two quantities, so your y-axis and your x-axis, without using specific numbers on the axis. So the graph tells you how the dependent variable, which is your your y, changes as the independent variable changes, your x. I'm sorry about that. Dependent is y, independent is x. So looking at this picture that you're going to draw, it is increasing, okay? It's a straight line, so that's a constant rate. This, no change, but it's still constant because it's a straight line, and this represents decreasing, okay? So we're going to use that to analyze graphs. That's where we're going to start, is looking at some graphs. So example 1, we're analyzing. So it says 2 graphs show the temperatures throughout the day in 2 cities. So we have Belfast, Maine and Newport, Oregon. So this problem has an A and a B. A says describe the change in temperature in each city. Then B says make 3 comparisons from the graphs. The comparison part is actually much easier than it sounds. So when we are describing the change in temperature, so the first one, Belfast, Maine. Okay, well, excuse me. So the temperature is increasing at the beginning of the day. Then it kind of begins, you could say decrease because it does slow down. Okay. Then it begins decreasing at a faster rate for the rest of the day. That's how we would describe that. It starts out increasing, you could say then it slows down, then it is decreasing. Okay, so because if you notice, it's not a straight line, it is curved. So then for Newport, you would say the temperature decreases at a constant rate because it is a straight line. That means it's constant, okay? Or it's at a constant rate. It could be it's dropping 1 temperature every hour. Who knows? So then the temperature stays the same for a while. So that's what that would mean. It stays the same. There's no change, which means it's constant. Then the temperature increases at a constant rate for the rest of the day. They even said the temperature stays the same for a while before increasing at a constant rate for the rest of the day. So you're just kind of having to describe the line. So then on comparing, so the things that they list, they said, okay, well, both graphs showed increasing and decreasing. Like this one increased first, then decreased. This one decreased, then increased. They both had increasing and decreasing. That's one comparison. Another comparison, which is the easiest one, is that they are both non-linear. This one might have 3 separate lines, but they are non-linear, which means the graph does not make just one straight line. And then the third comparison, they say, okay, well, in Belfast, it was warmer at the end of the day than the beginning. But in Newport, it was cooler at the end of the day than the beginning. Bam, 3 comparisons. They don't have to be anything super difficult. So now we're going to move on to example 2 before we try any problems. Now we're going to look at sketching a graph. Okay, so this says sketch a graph that represents each situation. So they give us 2 problems again. A says a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this constant speed for a while. Then it slows down at a constant rate until coming to a stop at the next station. So they represent that here, and they use each color to represent each part. So a stopped subway train. So that just means it starts from 0, 0. It gains speed at a constant rate. That word constant rate lets us know it is a straight line right there, okay? And we don't have to know where. Ours could have been more like this. It doesn't matter as long as it was a straight line and it's going up because it's increasing. It says until it reaches a maximum speed, okay? So that means it topped out and it travels at this rate, constant rate. So it maxed out, so it can't go any faster. So its speed is not changing, but time is. It's going at a constant rate for a while. Then it slows down, but at a constant rate. So it's going back down, but at a constant rate, so it's a straight line, until coming to a stop at the next station. Okay, so you would just draw your graph to represent that. Problem B says as television size increases, the price increases at an increasing rate. So on this one, it's right here. So as the television size increases, so as TV size gets bigger, the price gets higher at an increasing rate. So instead of a straight line, it's increasing, but it's changing the rate. Like it's not going at the same rate. So it is a curved line. It is increasing. So the graph is nonlinear because it becomes steeper and steeper. Okay, now you're going to try some problems. So let me scoot these up. You're going to try problem number 1 because you're comparing graphs, analyzing them. Then I'm going to go over number 2 with you, but I just want you to do number 3. You don't have to do number 2. Okay? You're just going to try 1 and 3, but then I'm going to go over all 3 of these with you. Okay, on problem number 1, let's get over a little so you can see the pictures. So it tells us the graph shows the paths of 2 birds diving to catch fish. Describe the path of each bird and then make 3 comparisons. Okay, so when we are describing each graph, so the pelican, if you notice there's no straight lines, it's all curved. Okay, so how we would describe that one is it is decreasing. You could say at an inconsistent or at a decreasing rate. Then it decreases at a faster rate. Then it decreases at a slower rate. That's all you're having to say, okay? So, and that's what you would write. I'm not going to write that down. But it says decreasing, you could say at I would say decreasing rate here. Then decreasing at a faster or increasing rate. Then decreasing at a slower rate. For the osprey, it is decreasing at a constant rate. Then it is decreasing at a faster constant rate, because it's again a straight line until it hits the water, but you don't have to say that part. Okay, so then 3 comparisons. So these are both nonlinear. They both were decreasing the whole time. Let's see, you could say it took them the same amount of well, we don't actually know that. I was going to say the same amount of time. Decreasing. They both changed speeds at least once. That one changed twice. This one just changed once. So you could say both changed rates. Let's be the technical term. Speed. I'll say speed for this problem. At least once. And there was other correct things. You can ask me if yours is correct, if you had something different. There's a lot of different things we can do there. You just have to list 3. Okay, so then on problems 2 and 3, it told you didn't have to do 2. I'm going to do it with you though. And then number 3. So number 2, we're drawing a graph that represents the situation. So number 2 says a fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left. That one was a little confusing, which is why I wanted to do it. So, let's see, we were talking about a battery and its charge. So, the battery loses its charge at a constant rate until it has absolutely none left. You plug it in and charge it fully, straight up and down. You lose its charge at a constant rate. That would be representative of number 2 because it loses its battery power at a constant rate, kind of like your Chromebooks. When you charge it, it charges fully. That just goes straight up. Then you use it and you lose battery at a constant rate until it has none left. Okay? Problem number 3, the one that you had to do, says as the available quantity of a product increases, the price decreases at a decreasing rate. So, as the product availability increases. So think of this as like buying a TV. The more and more availability of that TV, the cheaper the price. But it's not a constant rate. It tells us at a decreasing rate. So you know that the graph is either going to look like this or like this. So we have to pay attention to that. This one is going really fast. Okay, that'd be an increasing rate. This one, well, I guess technically, sorry, I said that wrong. This one is going fast because it's dropping quicker, but then it slows down. So that's what gets confusing about these. This goes fast and drops. So this one is a decreasing rate. I'm sorry if I confused you. I realize I mixed up my words there. So this one, it looks like it's dropping, but it is slowing down because it's not going straight down. It's not at a constant rate. It is at a decreasing rate. This one would be decreasing at an increasing rate. Okay, so as the availability increases, the price decreases at a decreasing rate. If it had been a constant rate, it would be a straight diagonal, but it is curved. Okay, example 3, we're interpreting graphs. This is still kind of the same thing as analyzing it, but now we're going to break down each piece with actual numbers and stuff. So this graph says this graph shows the altitude of an airplane as a function of time during a trip from Denver to New York City. Interpret the graph. So they went ahead and each separate line, they split into different colors for us. And so looking at that, it starts out at an altitude of 1 mile is kind of where they show us at 0 time. Then it goes straight, so a constant rate, and it's going up, so it's increasing at a constant rate. If you notice, from here to here is 1 hour, so halfway in that is 30 minutes. So after 30, it increases at a constant rate for 30 minutes, and it reaches an altitude of 7 miles. So they even say the plane increases at a constant rate for 30 minutes. We said that, at which point it reaches its cruising altitude of 7 miles above sea level. So they went ahead and said cruising altitude because if you notice right after that, it kind of like it levels out, which means they got to their maximum altitude. So then the plane flies at this altitude for 3.5 hours because it went from 30 minutes to 4 hours. So that's 1, 2, 3.5 hours. So it flew at that constant rate for 3.5 hours. Then it decreased at a constant rate for the final hour because it went from 4 to 5 before landing in New York City, which is at sea level. So they say that to let you know that it's at 0. They say it started out 1 mile above sea level. That's kind of how they worded that. And then they say the total trip took 5 hours. So you're just describing the same thing, analyzing it, but now in terms of the problem and using the numbers where possible. Okay, so you are going to try this one. If you can't, just watch me do it. It's okay if you're still a little confused on this. So number 4, it says this graph shows the distance of a mouse from its hiding place in a warehouse. Interpret the graph. So you're going to have to interpret all these changes in the line. You're using your own words, but you have to use words like constant rate, increasing, decreasing, and then throw in some numbers from the graph. Okay, so try your best, and if you can't, just watch me go over it with you. On example 4, we are having to, it says this graph shows the distance of a mouse from its hiding place in a warehouse. Interpret the graph. So yours might look a little different than mine, and that's okay as long as you have the gist of it, and some of yours might sound better than mine because you kind of have to make it into your own words. So if we look, this is the distance it is away from its hiding place. Down here is the amount of time it takes. So we're talking about a mouse. So there's multiple ways you can say the same thing. So I'm going to say the mouse starts out, that would be 20 if that's 40, 20 feet away from its hiding place. Kind of have a lot of writing on this one. Okay, and I'm numbering mine, you don't have to do that. Then we see it moves at a constant rate. Let's see, that's from here to here, so after 15 seconds, it's at 90 feet. So you could say, being that we're not necessarily increasing, decreasing, because it's a mouse running around, it's just getting further away and getting closer, you can kind of use it in terms of that since we're describing this specific problem. So you could say increases at a constant rate, or you could say after 15 seconds, travels, okay, so from 20 to 90 feet, that is 60 feet, travels 60 feet away from the hiding place. So after 15 seconds, travels, you do need to say a constant rate because it's a straight line. And I'm going to say to 90 feet away from hiding place. Or you could have said 60 more feet away. Okay, so that's up to here. Now it goes down or decreases at a constant rate again, back to 20 feet. And let's see, that was from 15 seconds to 35 seconds. That's 20 seconds. So I'm going to say traveled back. No, I'm not going to say that. I'm going to say traveled 60 feet closer to hiding place at a constant rate. Have to have that. Traveled 60 feet closer to hiding place at a constant rate over 20 seconds. I'm going to say ending up at 20 feet. Or actually, that's not where we end up, so I'm just going to leave it alone. Back 60 feet over 20 seconds. So that brings me here. Well, if you notice from here to here, it doesn't move. It's a constant, steady rate. From 35 seconds to 45 seconds. So that's 10 seconds. So stayed in the same spot, or stayed at 20 feet away for 10 seconds. I don't know where that S came from. Okay, that brings me to here. And then in, let's see, 45 to 50, so in 5 seconds, traveled 20 feet, because we went from 20 down to 0. 5 seconds, traveled 20 feet at a constant rate to make it to the hiding place. And again, your answers did not have to be exactly like mine. You mainly just had to have your numbers to represent where you were, and the main stuff is at a constant rate. Okay, if it had not been a constant rate, it would have been curved, and we would have had to say that. That's kind of the main stuff we're talking about when we are interpreting these graphs. The next thing we're going to look at is called a piecewise function. So if you want to write that word down, you can. With this definition, it says a piecewise function is a function defined by two or more equations. Just write that definition with it. You don't have to write the whole thing. It says each piece of the function applies to a different part of its domain, and we know the domain is the x values. An example is shown below. So these are a lot scarier than they look. To be honest, I actually really like piecewise functions. So what they're saying is this one function on this problem is split into two. And if you notice, these are both referring to 0. So that just means at 0, if x, your x value, your domain, is less than or equal to 0, this is what the graph will be, x minus 2. So if we look at this graph, they show us, so at 0, if it's less than or equal to 0, talking about the x-axis, it uses the equation x minus 2. But if x is greater than 0, not equal to, but greater, so we have an open circle, it follows this equation, which means go up to 1, but it's an open circle, up 2 over 1 for your slope. It represents that one. So it tells us the expression I can't talk, I'm sorry, y'all. The expression x minus 2 represents the value of f when x is less than or equal to 0. The expression 2x plus 1 represents the value of f when x is greater than 0. So you still might be a little confused at this point. That's okay. We're going to look at an example using this where I promise it's much easier than you think it is. So let me erase this and we'll look at the example. Okay. Example 4, evaluating a piecewise function. So it says evaluate the function, and they split this one into 2. They could have split it into 3. It says, so then they give us 2 problems, A and B. A, when x equals 0, and B, when x equals 4. So what you do on these, so that'd be the same thing as them saying, instead of x equals 0, saying find f of 0. We know that that means plug that number in for x. So you actually look at this part of the function first. So when x equals 0, and you see, if x equals 0, if I plug that in right here, is 0 greater than 0? No. So I can't even plug it into this one. But 0 is less than or equal to 0. So I can plug it into this one. So when x is 0, I can only plug it in to x minus 2. Okay, so that's what we do. We come up here and we say, okay, well, we can plug it into x minus 2 because it follows those rules. X is 0, so 0 minus 2 is negative 2. So f of 0 would be negative 2. Then for b, let me erase this. Let me switch colors. It says x equals 4. That's like saying find f of 4. Okay, so I go and I look again. Is 4 less than or equal to 0? No. Is 4 greater than 0? Yes. So I'm only going to be able to plug that into this part or this piece of this piecewise function. So I come down here, 2x plus 1, but now instead of x, I'm going to plug in 4. 2 times 4 is 8, plus 1 is 9. So f of 4 equals 9. Or they say the value of f is 9 when x equals 4. Same thing. So see, it's not that hard. You first just have to find out which piece it can fit in and then plug it into that piece. More than likely, it will not be able to fit in one or the other because otherwise your graphs would be overlapping. Okay, let's look at example 5 and then we'll do some problems. On example 5, we're talking about this graph over here to the left. So it says this graph shows the price per pound of animal feed when purchased from a wholesale seller. So we have 3 different parts. We have to describe the seller's discount policy, list the domain and range of each price, and then it says what's the price per pound when purchasing 20 pounds, 50 pounds, and 100 pounds. So on A, describe the seller's discount policy. So if you just look at the first part, so it looks like it is decreasing at a constant rate. Okay, so it says the price per pound decreases for purchases up to but not including 50 pounds. So what they're saying is right here is 50 pounds. If you notice, this one's open, this one's closed, so 50 is not included in this. But the price is decreasing at a constant rate. Okay, and then it says when purchasing 50 or more pounds. So when purchasing 50 or above, the price is $1.50 per pound. That's all it meant by describe their discount policy. It's just talking about in terms of this problem, describe the graph. So then when we talk about the domain and the range, okay, domain is your x value. So if you took these and we're only looking at the x, we have an open circle at 0 and an open circle at 50. Okay, so you don't include those as far as or equal to. So you would have to say your domain range is between 0 and 50, but just using less than symbols. And then right now we're just looking at the blue piece. And then for the range of that, that's looking at just your y. So if you look at it this way, let me draw lines. Like this way. We have it from 2 to 4, and it's, again, open circles, so it's not included. So your y has to be between 2 and 4. So greater than 2, but less than 4. Then when we're looking at the red piece, it's included at 50, and then it's an arrow, which means it goes on forever. So your domain on that one would just be x is greater than or equal to 50. And then when we're looking at the y, it never changes. So it's exactly y just equals 1.5. Then on C, it asks us, what is the price per pound when purchasing 20 pounds? So you're just looking at the graph. It's going to be hard sometimes to get an exact answer. So it said 20 pounds. So if I go up and look, it's kind of like right there. So they said it's about $3.25 per pound. To be honest, I probably would have said $3.50 per pound. It's kind of hard to tell. So both of those would have been a correct answer. Then it says 50 pounds. Well, we know at 50 pounds, it's exactly $1.50 per pound. And then 100 pounds, well, it's 50 and above. So at 100, which I guess technically is right here, it would still be just $1.50 per pound. Let's see. Okay, you're going to now try these problems. 5 all the way through 11. 5 through 10 use this function, the piecewise function. And then, so pause the video and write those down. But then once you get this wrote down for problem 11, I will scoot it back. Let me zoom out, excuse me. So that way you can actually pause it, because problem 11 refers to this graph. So there you go. Now you can pause it and work those out. Okay, on 5 through 11, so 5 through 10, we're looking at a piecewise function. These kind of look confusing just because they're new, but I like these. To me, these are easy and fun, but I think math is fun. So, okay, on F, actually, before we even do that, let's look at this function, the piecewise function. Let's break down what it means. These are the equations or functions if x falls into these categories. So this first one is only if x is less than -2. The middle one is if x equals -2 or greater than -2 all the way up to 5. It can equal 5, but it has to be smaller. And then this last one is this if x is greater than 5. So this first one, f of -8. So if I look, that's not bigger than 5. It's not between -2 and 5. It is less than -2. Okay? So it would fall into that one. If you notice, is there even an x in this? No. So no matter what we have, if it's less than -2, it just equals 3. That one's kind of confusing, but it just equals that because there is no x. On 6, we have f of -2. So this one is if it's less than -2. Here is where if x is greater than or equal to -2. So it falls in here of x plus 2. I plug in -2 for that. -2 plus 2 is 0. Number 7, f of 0. 0 falls between -2 and 5, so again, it goes in this one. So I plug that in. 0 plus 2 is 2. So f of 0 is 2, f of -2 is 0, f of -8 is 3. So my next one, f of 3. Let's see, 3, again, falls in this middle one because it's less than 5, but greater than -2. So I have 3 plus 2, which is 5. Next one I have is f of 5. We have 2 with a 5. This one, it has to be greater than 5. This one, it's less than or equal to 5. So again, that middle one, we have a lot that fall in that middle category. So we get 7. And then the last one, f of 10. That's the only one that fell in here because 10 is greater than 5. So I come back, that's 4x, which means 4 times x. On this problem, my x is 10. So f of 10 is 40. Okay, now let's look at 11. Okay, on problem number 11, it was just easier for me to do it on here instead of on the board. So we are referring to this graph. I can at least zoom in for it. And it said, in example 5, what is the price per pound when purchasing 1 pound? So if you look, 1 pound is like literally almost at 0. So I would say almost 4 if 4 was included, but since it is an open circle there, 4 is not. 1 is like literally right next close to it, so I would probably say that for 1 pound, it's $3.99. As long as you were somewhere close there, as long as you did not say 4, but somewhere close there, then it's correct. Okay, so then it said for 40 pounds. So looking at this graph, come up, it's right there, over here. I would maybe say 275, 280. Again, as long as you're close in there, then it's correct. And then the last one, do blue, said 83 pounds. Okay, well, we should know that anything above 50 pounds is all a set price. So wherever 83 pounds is, we know it's going to be $1.50. That's the only one that you had to have exact based on that graph. All right, and that is our lesson for today.